Hello students, welcome back to my channel once again. Whoever is watching for the first time, please subscribe the channel students, like the video and also share with your friends. Okay, so you might have understood the topic for today's video. That is experimental determination of transport numbers by HITTORF method. Yes, this is also an important question from electrochemistry students. Before watching this, kindly try to watch and understand transport numbers which I have already uploaded previously. Okay students. So before knowing what this HITTORF method is, kindly look at the apparatus, that is HITTORF apparatus, which was used by HITTORF to determine transport numbers. Okay, so here you can see in the figure, students, the whole is called as HITTORF apparatus in order to determine transport numbers. This apparatus you can find the anodic and cathodic compartments. Okay, so separated by an U-shaped middle compartment. Okay, so here you can find these two, the anode and cathodic compartments, and these two are separated by a U-shaped central or middle compartment. Now all the three compartments, you can see they are filled with a solution, and this solution is the experimental solution, students. Of experimental solution means whose transport numbers are to be determined. The same is filled here, the same is filled here, the same is filled here. Okay, and here you can find this is a silver coulometer. Okay, this is connected in series with these three compartments, and same quantity of electricity passes through the silver coulometer. Okay students, so here you can find a middle compartment, U-shaped middle compartment separating these two compartments, anodic and cathodic compartments, and they are filled with the experimental solution of known concentration, students, whose transport numbers are to be determined. And now a silver coulometer is connected in series with these three compartments, and why it is connected in series with these three compartments means the same quantity of electricity passes through silver coulometer also. Now whatever amount of silver metal is getting deposited on the coulometer gives fall in concentration both at anode and cathode, students. Okay, so silver coulometer, what is the purpose of the silver coulometer? So the amount of silver metal which is getting deposited on the coulometer, that is amount means what, in terms of gram equivalents we say. The number of gram equivalents of silver metal which is getting deposited here in the coulometer, it is giving us the fall in concentration both at anodic and cathodic compartments. You know what is coulometer, students? Yes, coulometer means, it helps us to determine the amount of a substance which is released during electrolysis by measuring the quantity of electricity that's being used. That is the purpose of coulometer, students. Okay, so here the silver coulometer purpose you must have understood, right? So this is connected in series with these three compartments so that the same quantity of electricity passes through the coulometer also. Okay, and now the amount of silver metal which is deposited in the coulometer, it tells us or it gives us the decrease in concentration both at anode and cathode. Okay, so have you taken a picture of this HITTORF apparatus, students? Below write down HITTORF apparatus used for determining transport number. Okay, coulometer, this is the coulometer. Fine. Now, how to know or how to determine transport numbers and what is the procedure or what is the process that is happening here. A current of 0.01 amperes will be passed for about 2 to 3 hours, students. Okay, it's not 2 to 3 minutes. A current of 0.01 amperes is passed for about 2 to 3 hours. So when current is passed, you should understand that electrolysis takes place. Okay. Now, after electrolysis, what happens? The solution, whatever experimental solution is taken here, that solution from anode or cathodic compartment, it is collected into a conical flask and its concentration is determined, students. Okay. Students, this is the apparatus, okay. Now once this apparatus is arranged, silver coulometer is connected. Now what are we doing? We are passing some amount of current. How much of current? 0.01 amperes. And for how much time this current is passed? For 2 to 3 hours. Now electrolysis takes place. Okay. So once after electrolysis, the solution from anodic or cathodic compartments is collected into a conical flask. How is it collected? You can see here. From here you can collect the solution after electrolysis and concentration is determined. Okay. Now the change in concentration in coulometer is also determined. Okay. From here or from here, the solution is collected after electrolysis and concentration is determined. From here also solution is collected and the change in concentration is determined. So here is the notes what all I have told, students. The apparatus consists of anodic and cathodic compartments separated by U-shaped central middle compartment. Okay, all the three compartments are filled with the experimental solution of known concentration whose transport numbers are to be determined. A silver coulometer is connected in series so that same amount of electricity passes through it. Next, the number of gram equivalents of silver metal deposited in the coulometer gives us total fall in concentration both at anode and cathode. Okay. Now what is the process that is taking place? A current of 0.01 amperes is passed for about 2 to 3 hours. After electrolysis, the solution from anodic or cathodic compartment is taken into a conical flask and its concentration is determined. The change in concentration in coulometer is also determined. Okay, students, change in concentration when we are able to determine after electrolysis. Okay, now let us see the concentration before electrolysis and after electrolysis. Have you noted down, students? Below write down concentration of the experimental solution around anode. Before electrolysis, let us say as X gram equivalents. After electrolysis, let us say Y gram equivalents. Fall in concentration at anode. Before minus after. So X minus Y gram equivalents. Okay. Now similarly, concentration of experimental solution in coulometer before electrolysis, let us say S gram equivalents, and after electrolysis, let us say Z gram equivalents. Now total fall in concentration in coulometer, that is at both anode and cathode, will be S minus Z gram equivalents. Okay, students. First, I told you na, either from anode or from cathode, the experimental solution is collected into a conical flask and change in concentration has to be determined. Here I have mentioned anode. Okay. So before electrolysis X, after electrolysis Y, fall in concentration X minus Y. Now from coulometer, the experimental solution is collected. Before electrolysis, let us say S gram equivalents. After electrolysis, Z gram equivalents. Fall in concentration in coulometer means it is giving fall in concentration at both anode and cathode. That is the purpose of coulometer, students. So how much it will be? S minus Z gram equivalents. Now how to calculate transport numbers of cation from this fall in concentration? Below write down transport number of cation. It is denoted by Tc. That's what I told you, students. Before learning this, try to understand transport numbers, which is also there on my channel. Transport number of cation Tc is equal to fall in concentration at anode by total fall in concentration at both anode and cathode. Okay. Now fall in concentration at anode, how much did we get? X minus Y. Here I have given, right? Now, so Tc is equal to X minus Y by both anode and cathode, that is fall in concentration in coulometer. How much? S minus Z. Are you able to see, students? Yes. Tc is equal to X minus Y by S minus Z. Now from Tc we can calculate easily Ta, because Tc plus Ta is equal to 1. So Ta will be equal to 1 minus Tc, students. Okay. We already know Tc. So from this Tc value we can calculate Ta. So therefore Ta is equal to 1 minus X minus Y by S minus Z, students. Okay. So from coulometer we can get fall in concentration at both, and so how much ever concentration is decreased at both anode and cathode, that we will be knowing from coulometer. Okay. So that is S minus Z. This is fall in concentration at anode. So 1 minus X minus Y by S minus Z gives the value of Ta. That is transport number of anion. Okay, students. So based on this also we will be having numerical, students. That also I have made one short video on numericals based on HITTORF's method. Kindly try to understand there. I did not read out the numerical, students. Directly I have shown you the solution. Kindly please watch that short video also and try to understand the numerical, students. Okay. So meet you in the next video with a new topic, students. Take care. Bye-bye.